Hello everybody. In this video we're going to be finishing off the week for notes, and we left off on this page, which is page 36 in your workbooks. So just a quick little recap of one of the things we did in the last video, which was graphing lines. Okay, the biggest concept of graphing a line is understanding the slope, or your rate of change, whether it's increasing or decreasing. It's always going to be that constant rate of change. Like for instance, we rise 3, run 1, rise 3, run 1, rise 3, run 1. That was hard to say. That doesn't change when you're graphing a line with a linear equation, that y equals mx plus b format, all of that we've already went over in the last video. Okay, when you start looking at some real world statistics and data from different scenarios, your data, when you graph it, doesn't typically get you a perfect line that follows that constant rate of change. You're going to be looking at these kind of plots at the top of page 36 in your workbook, which is more of a scatter plot. Okay, so scatter plots can follow a linear pattern, but they don't necessarily, like for example, rise 3, run 1, rise 3, run 1. They might be a different pattern, or they might not follow a pattern at all, but you can still tell that it has that linear relationship. Okay, so this table is supposed to help you identify different types of scatter plots, and we're going to use this concept of the line of best fit to go over them. So the first one I'm going to show you, and I'll highlight it as we go, is this one on the top left. That has the two words, if you look to the left, positive, and if you look at the top, strong. That first graph that I've highlighted is the first one we're going to look at. It has a strong positive relationship. So positive is very straightforward. It just has a positive slope, meaning it's going upwards when you look at it from left to right. Okay. The word strong means it has a very strong linear pattern. Linear just means it's like a line. Okay, so it has a strong linear pattern. If I were to draw in my line, first of all, just to go over something very quickly, we're not connecting the dots for these. That's not a line, okay? You never, ever want to connect the dots with a scatter plot. What we're going to do is draw this line of best fit idea, which means you just want to try and hit as many points as you can with your line. So that's my best estimation here of the line of best fit. Okay, so you can see that not all of the points on the scatter plot touch this line. Almost all of them do, but definitely not all of them. Okay, but because it's so close to being a perfect line, that's what makes it have this strong linear relationship, or in other words, correlation. That's a word we're going to get into a little bit later in the lesson today. Okay, but it's a strong pattern because it's really close to being a line, and it's positive because it's going up. Okay, moving on to this one down here. It's still underneath the strong category, but it's negative. Okay, so this one that I have highlighted has a strong negative correlation. Okay, the reason for that being negative, very straightforward, because reading it left to right, your pattern is going in the negative direction. That just tells you it has a negative slope. Okay, but the reason it's strong is the same reason that other one was strong. You can tell this is a linear pattern. If I draw in my line of best fit, it'd be about there. Yours doesn't have to be exactly where mine is. It's just the line of best fit. You're kind of estimating where it would be. Okay, but it's very, very close to being a line, just like the last graph that we did was. If it's close to being a line, it has a strong correlation. Okay, the next one we're going to look at is the top right. So this one's positive just because it's going in the positive direction when you read it from left to right. But now we're using the word moderate, kind of like a so-so relationship. Okay, so you can definitely tell it follows some type of linear pattern, like it's going in the form, like you can, what I mean by it goes in like a linear pattern is you can draw in a line of best fit and you can see the scatter plot has points that are generally following that pattern. That's what I mean by it has like a linear pattern. Okay, so there's my line of best fit, but something that you can definitely tell between the strong and the moderate one is that there are more spread out points for the moderate relationship. It's not as close to being a perfect line as the strong relationship examples are, so that's why it's moderate. It still kind of follows that linear pattern. As the values go up, they go right. As it goes up, they go right. It's certainly not constant, but the fact that it is not as close as the strong relationship is the reason it's called moderate. Really the same idea for this bottom right one. We've really gone over the whole gist of it, but it's a moderate relationship because it's not that close to being a perfect line, and it's negative because it's going in the negative direction. So for this one, just draw in your line of best fit as close as you can. And then the last example we're going to talk about real quick is this one off to the side. There's no correlation. So like where these ones are moderate and you can tell that they're generally forming some kind of linear pattern, they're moderate because they're not great like these strong ones are. That no correlation means you can hardly even tell that it's not supposed to be a line. Like if I drew in my line of best fit, it could be here, it could be here, it could be here. It's impossible to know what that pattern is, so there is no correlation at all. There's just scattered points all over the place. Okay, so what we're going to do for the rest of the notes today, and a little bit more than that, but for most of the rest of the notes today is something called linear regression. So what linear regression does, and it's actually really cool what your calculator can do, it takes all of the points in a scatter plot and it calculates these purple line of best fit equations that we came up with. Okay, so it takes all of the points, it finds that average slope between them. Even though there's not a constant rate of change, it finds the slope of what this line would have as a constant rate of change, that line of best fit. And it also finds the y-intercept that it would cross through given the points with that slope. Okay, now there's really not much you need to do other than follow the process of doing it in your calculator. It's kind of nice. A lot of students really like this because it requires less thinking and just a lot of button pushing. So relatively easy. Before we get into the step-by-step, I really need you to focus on this highlighted part of your workbook right here. You need to be in the right mode in your calculator for this to work. And that mode is having your diagnostics on. So I'm going to walk you through that on the calculator. Let me get out of this. Okay. So to get to your mode of having your diagnostics on, you're going to hit the second button on the top left. And then you're going to press 0. So second 0. Oops. Second 0. Again, you might have a different calculator looking screen, but it's about the gist of this. What you need to do is just scroll down, either scrolling like this or using your down arrow until you see the words diagnostics on. You know, you might be looking at mine like I'm losing it. If you have the exact app that I have, your diagnostics are actually already on. I just wanted to kind of show you where you would find it if you don't have this exact app. So if you have my app, your diagnostics are already on and you don't have to worry about the mode. All of you other people that are either using the handheld actual calculator or the Android app, you're going to have to turn your diagnostics on. So if you look back at your notes, it says second 0, scroll down to diagnostics on, and then you have to press enter twice. So once you get diagnostics on, you just hover over it. So your calculator's highlighted on it, press enter twice, and your calculator will say done. That's how you know you've put it in the correct mode. Your calculator will say done, and that means it's in diagnostics on mode. Now, awesome news is that is the only time you're ever going to have to put it in that mode. Your calculator will stay in that mode now. Okay, so that was like a one and done. You don't have to worry about that anymore. So I'm just going to go back to my notes now. We are in the right mode, so we are good to go. Now, before we get into the step-by-step, this that I'm boxing in right now, you're going to love this part too. This step-by-step inside of the box is going to be given to you on tests and quizzes. Okay. those step-by-steps, I know you're kind of using everything open notes as it is, but that step-by-step will be given to you on tests and quizzes, available at the question that you need it. So why on earth are we practicing it? Because you really want to get comfortable with your calculator, okay? So the step-by-step will be given to you, but you need to know how to follow the steps in your calculator. So I'm going to stay on my calculator screen and show you the step-by-step for this, but the first thing I want to do is actually talk about the question. Okay, so 154A says determine the equation of the line of best fit, which is what I told you that linear regression will be doing, but the question even says using linear regression for the following data. When necessary, round to the nearest thousand. So we'll talk about that when we get there. Okay, but we're going to use this process for linear regression with the following data, which is actually given above. So let's just talk about this data for a second. Okay, it's always going to be given as X and Y, whether it's labeled or not. It's usually labeled, it's just not for this one. Okay, but your X variable, it'll always be on top. If it's like a top and bottom chart like this one, it'll be X on top, Y on the bottom, or you'll be given a table like this where X is on the left and Y is on the right. Okay, but the X variable for this table is age in years, and the Y value is height in inches. So these people that are, hypothetical for this example, documented the age and height of certain people. So a 3-year-old that they took the data on has a height of 35 inches. A 9-year-old has a height of 51 inches. A 21-year-old has a height of 67 inches, and so on. Okay, so this is that real life scenario data that I was kind of talking about in the beginning of the notes, where it doesn't follow a constant pattern. It's not like for every 1 year you increase in age, you gain 3 inches in height. It just doesn't work like that. It's not a constant rate of change. You'll even notice right here, an 18-year-old is 75 inches tall, and then the 21-year-old is shorter than that. Okay, so it's just data, real life statistics. You can't have a constant rate of change. Well, you can, but more often than not, you are not going to have that perfect line or that perfect rate of change. Okay, so that's the scenario we're working with. Now let's go to the step-by-step in the calculator. Keep your notes handy. I'm just going to jump to my calculator. Okay, so step 1 says to press Stat and then choice 1, Edit. So I'm going to press Stat, which is this button right here. And then you're going to choose choice 1, which is Edit. And this should come up. Probably not those numbers, but this is what's going to come up. Okay, it even tells you in step 2 how to clear these out, but I'm just going to walk you through it. To clear out your lists, this L1, L2 thing you see on here, they're called your lists. To clear them out, you're going to use your arrows to highlight over them. So notice how I'm highlighted over L1 right now. And then you press Clear, Enter. You never want to hit delete. Okay, do not delete your list. If you do, please reach out to me ASAP and I'll help you fix it. You want to hit clear. We're just clearing out the information on our lists. Okay, as said, clear, enter. Some of you only have to press clear. It just depends on whatever calculator you have. If you hit clear, enter, you're good all around, no matter what calculator you've got. All right, now the rest of step 2 says to plug in the X values into your L1. So notice where I'm highlighted right now. I'm in the first box underneath L1, and I need to type in my X values. So the first X value I see in my table is 3. So I'm going to press 3, enter. The next X value is 6, so I hit 6, enter. Then 9, enter. 12, enter, and so on. Okay, once you have all of those plugged in, we're going to move on to step 3. It first tells you to clear out your L2, but we already did that. But now it wants you to plug in your Y values into L2. So hit your right arrow key to go over to L2 and do the same thing, but type them in the same order. It's crucial that like 3 and 35 match up, 6 and 46 match up, and so on. Okay, pause the video if you need more time to plug these in. I'm going to tell you something super, super important about this. if you plug in any of these numbers incorrectly, let's say that last 67 number, I accidentally typed in like 76. I just messed it up. Your whole answer will be wrong. So if this was a test or a quiz, I would highly, highly, highly give you the advice to scroll back and just make sure you typed in the numbers correctly. Okay, it'll take you like 2 seconds to just double check, but there's no way for me to give you any partial credit for work on this type of problem. If you type in one of your numbers wrong, the whole thing is wrong, and I don't like doing that. So please take a second to double check that you've plugged in your numbers correctly so that you can get your answer right. Okay, so that is steps 1, 2, and 3. We are on step 4 right now. So step 4 says to press stat, your right arrow over to calc, and then choice 4. And the reason I went back to my notes is to show you this. It literally tells you in the problem to do linear regression. Your calculator wants you to press linear regression. It's like, obviously. Okay? So stat is that same button we started with. You hit your right arrow, or if you have my calculator, just press the calc on the top. And then choice 4 says lin reg. So you're just going to select that. And now it does say for the next step to press enter until your results show up. You literally just keep pressing enter until this screen shows up. If it says error, just ignore it. I don't know why it does that. It's just a glitch. There's no error. This is the correct information. Okay? So some of you that have the actual calculator, you might have to press enter like 6 times, but this is the screen you want to get to. Okay, if you have this identical screen, you're awesome, okay? You did it perfectly and you are in good shape. If you don't have this screen, there's a good chance, if you have like your A and B are wrong, that means you've plugged in one of your numbers incorrectly. If you don't have those R's at the bottom, that means your diagnostics are not on. Okay, if you're having any other issue, please just email me and I'll try and fix it for you as soon as possible. Okay, but this is the information that I have. Now focusing on this screen, I have y equals ax plus b at the very top. That should sound very familiar to you. I know we haven't used ax plus b, but we were using y equals mx plus b. The calculator just uses a instead. It's no big deal, but it's the same type of equation and the same idea where a, in this case, where m should be, is our slope and b is the y-intercept. Okay, so ignoring the r values for now. We'll get into that a little bit later. What I want you to do is copy that information down. So y equals ax plus b, and then a is that long decimal, then b is 33. Okay, I'm actually going to go back up to my steps because we didn't finish step 5. It said enter until results show up, and that's as far as we got, and we just copied it down in part of our answer slot. But then it says to substitute values into equation form and round. A lot of people skip that step, but that's literally your answer. So remember what we did in the last video where we needed those crucial numbers of m and b. I know it's a and b for this, but just stick with me. It's the same idea. Once you have your m and your b, you can write out your equation, and that would be your equation for the line of best fit, and you would be done. So that's all we need to do at this point. Problem is they're not rounded. Okay, so it does say when necessary, round to the nearest thousandth. So thousandths is 1, 2, 3 places after the decimal point. Okay, so if I'm rounding to 1, 2, 3 places after the decimal point, I do need to look at that 4th digit. 5 or above, give it a shove. That 1 does not have enough power to bump the 6 up. So when I round this, it's just going to stay 1.976, and I'm going to get rid of the rest of the decimal because that is those 3 decimal places I need to be rounded to the nearest thousandth. Okay, so I took care of rounding. That's done. But now I need to substitute values into the equation form. So this is my A value. I'm going to plug it in where I see an A. And 33 is B, so I'm going to plug that in for B. So your overall final equation is going to be y equals, in place of A, I'm going to do 1.976 Remember, after the A comes the X, so X comes down, and then plus B is going to become plus 33, and that is your final answer. So what that is, I know it's definitely an uglier equation for y equals mx plus b than we're used to, but that is the equation for the line of best fit. So if all of these points were plotted from the table on a grid and we drew the line of best fit, this would be its equation. Okay, so speaking of if those points were graphed, let's look at the next page. I'm actually going to jump down to part C. Okay, we're going to go back to part B, but just look ahead to part C for a second. Okay, so this is our table, same table that we had above. Ignore this part for now. We'll talk about that in just a second. But what I did for you, because it's just a lot of work, to take these points from the table and I plotted them on this grid. So you can see that this definitely has a positive relationship because it's going up, and it's a strong relationship because if you drew in that line of best fit, it'd be about here. All right, hopefully you would agree with me on that. That's a really close line of best fit. Okay, so it has a strong positive correlation. It is a really close to being a linear relationship, and that is my line of best fit. Now that blue line that I draw in for the line of best fit has this equation. That's the equation we just got up here in the last example. It's your equation for the line of best fit that your calculator calculated. So if you look, your B or your y-intercept is about 33, and you'll notice our line of best fit has a y-intercept of about 33, and its slope is about up 2 over 1. It's kind of hard to tell because our scale is going up by 10, but at about, just trust the process here, it has a slope of about 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, and so on. Okay. Now, these are the actual data points from the table. So a 3-year-old that they studied is 35 inches tall. A 21-year-old is 67 inches tall. Okay, I'm going to draw your attention to one specific point. Let's focus on, let's do this one. 1875 is this point right here. See how that point is not on your line of best fit, but it's just part of the scatter plot. Okay, so the estimated point was saying that an 18-year-old would be about 70 inches tall, but the one that was studied was 75 inches tall. So see how this equation that your calculator came up with is just an estimation. It's not an exact representation of the scatter plot or the exact people that were studied. It's just an estimation. They're estimating based on the rest of this data that an 18-year-old would be about 70 inches tall. So this must be just a very, very tall 18-year-old. That's why he actually falls above our line of best fit. Okay, so this drawing right here that I graphed for you of the actual data points. So going back to that, oh no, there we go. So kind of like going back to ignoring that line of best fit and just looking at our scatter plot. We talked about how this has a strong positive correlation, which is just another word for relationship or even pattern, if you will. Lots of different words you can use. Okay, it's strong and positive. Positive because it's going up, and strong because if you look, it's really, really close to being a perfect line. Okay, now to tell that this had a strong, positive relationship, I plotted it for you. Nobody, and I imagine every single one of you watching this video, would want to actually go through the process of scaling your axes and plotting all of these points to see if it has a strong or a moderate or no correlation. Nobody would really want to do that. I did that so you can visualize it. But there's something cool. Your calculator will actually tell you whether or not it has a strong, a moderate, or a weak, or just no correlation. A weak is the same as like no correlation. Okay, so it's called your correlation coefficient. You don't have to do any further calculations. It's actually already on your calculator screen, and it is the R value. The R value is known as your correlation coefficient, and it tells the strength of a relationship. So here's how it does it. It's just something you need to remember. If you remember it, you won't ever have to go through this whole graphing process. I'm trying to save you some time here. Okay, so before I even go over this, look at part B. The question just says state the correlation coefficient, and it even says that's the R value on your calculator, based on the linear regression, and describe what it means. When it says describe what it means, it's asking you, is it strong? Is it moderate? Or is there no correlation? And it's also asking you, is it positive? Or is it negative? Okay, you're going to have two words to describe the correlation coefficient. And like I said, rather than actually graphing it, you're going to pull it from the number. Okay, so the R value, this whole thing that I started right here is the most important part. The closer this R value is to 1 or -1, the stronger it is. Okay, so you're not going to have a number outside of that range. -1 is going to be your highest. Your lowest, and +1 is going to be your highest. You're never going to have a correlation coefficient of like 2 or -5. It's always going to be within that range of -2, oh my God, I'm so sorry, of -1 to +1. Okay, the furthest you can be from -1 and +1 is 0. That's why it's right in the middle there. 0 represents no correlation. So if you have an R value in your calculator that's 0, that means it's no correlation, and it looks like that no correlation graph that we had at the beginning of these set of notes, this video. Okay, halfway between no correlation and 1 is going to be these 0.5 or -0.5. That's going to represent your moderate relationship. Kind of like it's okay, it's so-so, it's not a perfect line, but you can tell it's following some kind of linear pattern. And then 1 is a perfectly strong, like super close to being a line, linear pattern. Okay, the difference between the left side and the right side from this 0 is whether it's positive or negative. Okay, that's really the only gist here. This is a -0.5, so it's a negative correlation. And a -1 is also a negative correlation, just meaning that the graph is going down. These ones where it's positive just means that your graph is going up. And again, no correlation, it's just all over the place. There's no pattern at all. Okay, so some people typically ask me at this point, I know you really can't be asking, you can't really ask me questions at this exact point, but like what if you have a 0.6? 0.6 is closer to being moderate than it is to strong. So you would call that a moderate relationship as well. It doesn't have to be an exact 0.5 or an exact 1. You might have, let's say, like a -0.9. A -0.9 is still going to be a strong negative correlation. A positive 0.9 is also going to be strong, but it's going to be strong and positive. Okay, if you have, let's say, a 0.1, that's closer to 0 than it is to 0.5, so that's going to have no correlation. So really, it's just kind of like, where does it fall closest to on the number line? I usually also get the question, what about like 0.25, where it's like equidistant from 0 and 0.5? I promise you will not see a 0.25. You will never see something that's that exact. You won't see a 0.75 either. Okay, you're going to see values that are either really close to 1, really close to 0.5, or really close to 0. You will know. So let's do our first example from our information on this calculator. Okay, so we only used A and B before. We're going to now look at R to figure out the correlation strength of this data. There we go. So you'll notice there's an R squared and there's an R. You will never, ever, 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 ever use R squared. It's always going to be R. So the first part of this correlation coefficient question is to just state the R value. So from the calculator, I'm just going to write what the R value is. It was 0.9418449191. Just double check that. Oh, 9418449. Yeah, that's right. It's a little bit longer, but that's plenty. Okay, so that was just stating it, and I'm going to add to your notes just so you remember, never ever use R squared, ever. Okay, it's always just going to be the R value. Okay, so I need the two words. First, is it strong, moderate, or no correlation? I have 0.94. 0.94 is up here, really close to +1. So it's going to have a strong positive correlation. And that is the answer to describe what it means. It is a strong and positive correlation. And that would be all you would have to do for that type of question. State what it is. It might ask you to round it. This one didn't. And then describing what it means is just strong, moderate, or no correlation, and then whether it is positive number or negative number. That, knowing this number line right here, just like whether it's close to this or whatever, to figure out if it's strong or moderate, is a lot easier than actually graphing it to try and figure out if it's strong, moderate, or no correlation. Another way to think about it, if it helps, is like money. If you're not really sure whether it's close to something or not. This is like $1, and this is like 94 cents. 94 cents is super close to $1, so that would mean that it's, you know, a strong relationship. 94 cents is much closer to $1 than it is to this right here, which would be 50 cents if we're talking about money. So sometimes money helps when you're talking about decimals. All right, moving right along to the next page. Before we hit that, your code word for this video is red. Make sure you write that down. You will be asked that on your next quiz. So your code word for this part 2, week 4 notes video is red. All right, so we just talked about a correlation coefficient. So we already kind of know what correlation is, but it's just essentially the relationship among your data. Okay, another word that gets confused with correlation is causation. Causation kind of sounds like cause. It's essentially a cause and effect relationship. Oh, man, I knew it was going to happen. Oh, I'm on the homework. I don't even know where I am. Here we go. Cause and effect. Oh boy, relationship. Okay, cause and effect relationship. Now the fancy definition that I have written here is that one variable influences the other, like something causes something else to happen. Now remember, our last example that we worked on was talking about age and height. So for 155A, it says, did our previous example display correlation and or causation? Explain. Let's start with correlation. That answer is definitely yes. We already talked about that. There was a relationship in the data between age and height. Okay, as age increased, height increased. That is a relationship. So yes, absolutely. Now, on the other hand, causation. Did one of our variables cause the other one to change? Did age cause your height to change? Think about it for a second. Okay. Did age cause height to change? Hopefully you are thinking, no way, Jose. So to kind of like put it into perspective for you, where I said, did age cause height to change? Yes, there is a relationship. There is a correlation because yeah, as your age increased, your height typically did increase. But did it cause it? Like, did you blow out the candles on your birthday and instantly gain 3 inches? Absolutely not. That did not cause it to happen. It just so happens to work out that way. So your explanation for the specific example would be that causation is a no. It is not causation. Okay, not causation. That word looks so weird. Because increasing in age does not cause, it does not cause height to increase. Again, yes, there is a relationship in that data, but it doesn't cause it to happen. In other words, sometimes this kind of helps with the explanation. You are not getting taller because you are getting older. Again, it just so happens to have that relationship. You're not getting taller because you're getting older. It's just happening. Something else that might help you determine causation with, or the difference between the two, I should say. Within our data that we had, as age increased, height increased, but we only went up to 21 years old. What typically happens around like 18 to 21 years old? Yeah, you stop growing, okay? After 21 years old, you typically stop getting taller, okay? So like, if we're talking about this specific person, they might hit 25 years old and still be 67 inches, and then 30 years old and 67 inches, and that wouldn't change. So it's definitely not causing an increase because eventually that pattern dies out. Whoops. Okay, so part B is also something that might help you understand this idea of causation a little bit better, is to provide an example that represents causation. An example I typically give that helps people understand is if you work more hours at an hourly paid job, I don't even know why I try. Here we go. At an hourly paid job, your paycheck will be higher. Okay, if you work more hours at an hourly paid job, your paycheck will be higher. Your paycheck is increasing because you worked more hours. It didn't just happen to work out that way. You literally worked an extra hour, your paycheck went up an extra hour in pay. You work an extra 5 more hours, your paycheck goes up an extra 5 hours more in pay. And again, I specified for an hourly paid job because salary paid jobs would be an exception here. If you work more hours, your salary does stay the same. But like, just that kind of specific example might help you understand causation a little bit more. Another one that people have used is if you drive more, there are less gallons of gas in your tank. Okay, so the more miles you drive, the less gas in your tank. I thought I got away with it that time. The less gas in your tank. Okay, there are so many different examples, but like for that one, the more miles you drive, the less gas is in your tank because driving more causes you to use gas, so there would be then, as a result, less gas in your tank, cause and effect. It doesn't just happen to lose gas. It's a result of the thing that's happening. Okay, that's the big difference between correlation and causation. Correlation for this one, another example of correlation, if that'll maybe help you understand too, is like I usually use age. Like as your age increases, your reading level increases. Like as you get older, you happen to get better at reading, but it doesn't happen because you got older. Another one, it's kind of similar to this one, but as you get older, your shoe size increases. It doesn't cause it to happen. You don't, like I said, blow out the candles on your birthday and all of a sudden your foot's bigger. It just doesn't work like that. It happens to have a relationship because as you get older, you grow, but it's not causing it to happen. Okay? So there's some few examples that hopefully help you determine the difference between the two. And then this last example in your notes actually has the answer written at the bottom. It's just another practice of linear regression for you to work on if you so choose to do so. So if you want another practice example using that step-by-step, go ahead and try that in your calculator. Give it a pause right now. I'm just going to jump into it to show you it. And if you don't think you need this, then just don't even bother with it, okay? So the step-by-step is to go stat, and then over to edit. To clear them out, you clear enter, highlight over L1 and L2, hit clear enter, and type in those numbers. Don't change the order of them, just type them in exactly how you see them. I know these are bigger numbers, so be very careful typing them in. Definitely, because these numbers were bigger, I highly recommend going back and just making sure you plugged in the numbers correctly, because your whole answer is determined based on whether or not you plugged in these numbers correctly. So be very careful. Okay, once you have them all plugged in, you press stat, go over to calc. This is step 4. And we're going to go down to choice 4, like it says in the step-by-step, which is linear regression. And then you just press enter until this comes up. That error message, just ignore it. You don't actually have an error. Okay, and this is only asking for the equation, so I only need y, a, and b. So my y equals ax plus b. Okay, you copy down your a. I actually don't have this, so let me just... Okay, so a is -3, 4, lots of numbers here. 7, 3, 9. Oh, man, every time. 3, 4, 7, 3, 9. 0.71 to 91866, and B is Okay, now going back to the directions, because I don't even know if I read them for this. It says determine the equation of the line of best fit using linear regression for the following data. Round all values to the nearest tenth. This one's not asking about the correlation coefficient at all, so we don't need the R value for this one. You're only going to use R if it's asking you specifically for your correlation coefficient. For this, where it's asking for the line of best fit, I'm going to use that y equals ax plus b. And then finish out step 5, which says to round and substitute those values in. So this one wants me to round to the nearest tenth. If I'm rounding to the nearest tenth, that's only one place after the decimal point. So that would be right here, but I still need to look. I was trying to avoid it. Oh my goodness. Okay, but you still need to look at that next digit after it. 5 or above, give it a shove. So this one's a 9. It's going to bump that 0 up, but this one is a 1. It is not going to bump that 7 up. So A is actually going to be -34739.7 when rounded, and B is going to be 313309.1 because the 9 bumps the 0 up to a 1. Now that you know what A and B are, you can plug them into this format right here. So my final answer is going to be y equals When I plug in A, it's negative 34739.7. Make sure you bring down that X. And then plus B is going to be plus 313,309.1. I know those are bigger numbers. Okay, you really won't see big numbers like that on a test or a quiz, but it's just a good example to go over. Okay, so something we didn't see in the last one was a negative slope. If you think about the situation, which we didn't even talk about, the X value is number of blocks from the beach. Oh my God, I'm gonna lose it. Okay, and the Y value is the price of a cottage. If you think about it, as the number of blocks from the beach increases, that means you're getting further and further from the beach. So it makes sense for the price of the cottage to decrease, making there have a negative slope for this scenario. Because the further you are from the beach, typically the less value your cottage has. If you're right up on the beach, along the water, it's more expensive. Whereas if you're further away, it might be less expensive. So that's why there is a negative slope. It's going down as the number of blocks from the beach increases. Something else just I'm going to go over really quick is the R value. If you look at R for this one, it's negative 0.987. So R is negative 0.987, I think. Did I say that right? Yeah. So I know it didn't ask for it, but just to go over that concept again, those two words that would describe this correlation coefficient would be negative because it's a negative number. And then try and think about it. Is this one strong, moderate, or no correlation? Okay, it's certainly negative and strong because it's like 98, 99 cents if you round it to the nearest hundredth. That's really close to the -1 on my scale, and -1 is over here by strong and negative. Okay, so that's the whole idea for correlation coefficient. There's your equation for that last example. If you did it, awesome, you got that more practice in. It's just getting comfortable with your calculator and knowing what your final answer should look like.